Everyone, welcome to the discussions of the past year questions. This video which I'll discuss about the mechanic, paper 4, May, June 2024, paper 43. Let's take a look at the question number 1. Two particles P and Q of masses 0.2 kg and 0.5 kg respectively are at rest on the smooth horizontal plane. Particle P is projected with a speed 6 meters per second towards Q. After P and Q collide, P move with a speed of 1 meter per second. Okay, then find the two possible value of the speed of the Q after the collision. So over here we can have a diagram. We have a P here and we have a Q here. They are resting on a smooth horizontal plane. P is moving towards to Q with a speed of 6 meters per second. Okay, that is before. But after the collision, P moved with 1. But the 1 over here, they didn't mention left or right. So we need to assume can be left. It also can be right. Okay. So by the principle of conservation of linear momentum, that means we have two cases to consider. We have a case number 1. Okay. So by the principle of conservation of linear momentum, we have the MP, UP, plus the MQ, UQ is equals to the MP, and this one is a 0.5 VQ. This one I assume that the P go to the 1 meter per second to the right hand side, okay, to the positive directions. So from here, just press a calculator, you can find that the VQ is actually 2 meters per second. This is one of the possibility of one of the possible value of the speed of Q after the collision. Then we have a case number 2. Case number 2, also principle of conservation of linear momentum. We have a 0.26 plus the 0.50. This time, the speed of the directions of the motion of P is reverse. And this one, the VQ, we do not know. Over here, let me try to squeeze everything inside. This is a 0.5 VQ. Then we can find that the VQ is actually 2.8 meter per second. Just like that, done. So therefore, these are the two possibility of the speed of Q after the collision. That's all done. Okay, moving on, we have question number 2. Okay, now we take a look at question number 2. A particle of mass 0.2 kg is attached to one end of a light inextensible string. The other end of the string is attached to a fixed point O on the vertical wall. The particle is held in equilibrium by a force of magnitude x Newton, perpendicular to the string with the string taut and making angle 30 degrees with the wall. See the diagram. Find the tension and the string and the value of x. So over here, this will be your weight. It will be 2 Newton. This will be your tension. And this is a 30 degree. This is also 30 degree. So first of all, if we have this diagram with us, it will be easier for us to find the answer. So first of all, from the diagram, we resolve the forces vertically. You have T cos 30 plus the x sine 30 is equal to 2 Newton. So it will be sec 3 over 2 Newton T plus the half x is equal to 2. We can make it become sec 3t plus x equals to 4. That will be the first equation. Then now I resolve the forces horizontally. I have the T cos, I have the T sine 30 is equal to the x cos 30. So it will be half t is equal to the sec 3 over 2x. That means the t is actually sec 3x. That will be your second equation. Substitute 2 into 1, you will be having the 3x plus x is equal to 4. That will give you x is equal to 1. From the equation number 2, your T is equal to 3 Newton. This one also write Newton. Just like that, done for the question number 2. So quite simple. Okay. So now we'll move on. Question number 3. Okay, now we take a look at question number 3. A car travels along a straight road with constant acceleration a meter per second, where a is positive. The car passes through point ABC in that order. The speed of the car at A is u meter per second in the directions of AB, and the distance BC is twice the distance of AB. The car takes X seconds to travel from A to B in 10 seconds. And 10 seconds to travel from B to C. So we have a diagram here. We have A, we have the B, we have the C. Okay, so you start from here with the speed u. Okay, going these directions. This is the speed of the B. Okay, now after here you reach here with the speed of the C. Okay, the car takes 10 seconds. X seconds, sorry. Then from here to here, it will be 10 seconds. Okay, so given that the BC is equal to twice the AB. Okay, so this is what we have. Okay, so what you can do is that the acceleration throughout the whole motion, the acceleration is constant, a meter per second. Okay, so we just say that consider the case of A to B. So for A to B, we are having the distance AB is equals to the UT plus half AT squared. Okay, so it will be, we do not know the U, but we know that it will take X seconds. This one is a 32A. Okay, so that is a AB, number 1. Then A to C. I don't want to consider B to C. I consider A to C directly. A to C, it will be AB plus BC is equal to the UT plus half AT squared. Also, then this one, because of this reason, we have this one as a 3AB equals to the total time over here is, the total time is X seconds plus 10 seconds. So it's 18U plus the half A of 18 square. Okay. So over here, we are having AB is equal to the 6U plus the 54A. That will be your second equation. So we let our first equation equal to the second equations. We have 8U plus the 32A is equal to the 6U plus the 54A. Therefore, you have the U is equals to the 11 over 2A. Hey, sorry, make a mistake. It's supposed to be 22 over 2A. 22 over 2 is 11A. Okay, just like that. Done. That is the answer for the question number 3, part A. So now we're moving on. We want to find the speed of the car at C in terms of A. The speed of the car means we want to look for the VC. How much is the VC? So by using the formula, VC is equal to the U plus AT. Okay, since we know that the U is 11A, and the time taken is 18 seconds, so the answer it will be 29A. Just like that, done. This will be the answer for the question number 3B. Now moving on, we have question number 4. Now we take a look at question number 4. A particle travels in a straight line. The velocity of the particle at time t second after leaving the point O is v meter per second, where the v is given as the kt square minus a 4t plus 3. The distance traveled by the particle for the first 2 seconds of its motion is 6 meters. You may assume that the V is positive in the first 2 seconds of its motion. Okay, so the first 2 seconds, and then assume first 2 seconds the V is positive. That means the particle will not turn the directions. Okay, so over here we can actually straight away say that the formula will be just integrate from 0 to 2 kt square minus a 4t plus 3 is actually equals to the distance that you travel, 6 meters. Okay, straight away. Then just integrate, you get kt cube over 3 minus a 2t square plus the 3t from the 0 to 2. Substitute the value 2 inside, you get 8 over 3k minus the 8 plus the 6 minus the 0. So you get a k is equals to 3. Just like that, done. That will be the answer for the number 4A. Now moving on, question number 4B. Find the value of the minimum velocity of the particle. Do not need to show that the velocity is minimum. So to find the minimum velocity means we have to find the dv dt lah. Our v is, we replace the k that we found earlier, change the k become 3. Okay, so from here we want to find the acceleration. That means the dv dt, that will be 60 minus the 4. Okay, so dv dt equal to 0 in order to get a minimum velocity. So your t is 2 over 3. Okay, so when the t is equal to 2 over 3, since I do not need to show that the velocity is minimum, we straight away just write this one, the v as a minimum. Okay, the v minimum, it will be the k t square minus a 4 times t plus the 3. So press the calculator, you get this one as a 4 over 3 minus a 8 over 3 plus 3. So you get the answer as 5 over 3 meter per second. Done. This will be the answer for the number 4B. And moving on, we have question number 5. Okay, now we take a look at question number 5. A van of 4,500 kg is towing a trailer of mass 750 kg down a straight hill inclined at an angle theta to the horizontal, where the sine theta is a 0.05. The van and the trailer connected by a light rigid tow bar which is parallel to the road. There are constant resistance forces of 2,500 Newton on the van and 300 Newton on the trailer. Given that the tension in the string is 450 Newton, find the accelerations of the trailer and the driving force of the van's engine. So we are having a diagram. So we have the van towing a trailer. Okay, so this is going down the hill. You have the tension here. You have the tension here. You have a resistance here as a 2,500 Newton. And you have a resistance here is 300 Newton. Okay, so this is the theta. The sine theta is 0.05, which means the theta is an arc sine of 0.05. Okay, so we consider the van. So if we consider the van, your driving force minus the mg or plus the mg sine theta. This is the mass of the the van. So it will be mvg sine theta minus the t then minus the resistance force. The resistance force is 2,500 is equals to the 4,000 MVA. Maybe we put MVA. Okay, so the driving force, I do not know. This one, it will be 4,500 times 10 times 0.05 minus the tension given as a 450. So we just write 450 minus a 2500 is equal to the 4,500A. Okay, so just simplify it. You will get this as the driving force equals to the 4,500A plus the 700. Okay, so this is what we have for the first equations. Now, if you consider the trailer, it will be the T plus the MT G sine theta minus the resistance, and then is equals to the 750A. Okay, and also the trailer, the tension for the trailer is given as a 450. Your mass is 750 G sine alpha 0.05 minus a 30 minus a 300. So from here you can find the A. So the A will be a 0.7 meter per second square. Okay. Now we can put this answer into the first equations. So if you put it into the first equations, you will get this as the 4,500 multiplied 0.7 plus the 700. Press a calculator and you can get the answer as 3850 Newton. Done. This will be the answer for the question number 5A. Okay, so now we're moving on to the B. Okay. On another occasion, the van and trailer ascends a straight hill inclined at an angle alpha to the horizontal, where sine alpha is equal to 0.09. The driving force of the van engine now is 9,100 Newton, and the speed of the van at the bottom of the hill is 20 meter per second. 20 meter per second. The resistance to the motion is unchanged. Okay, find the accelerations of the van and the tension in the towel bar. So now they change the directions of the motion. They are going up the hill right now. Okay, so this time this is alpha. The alpha is a arc sine of 0.09. So it's going up the hill. Okay, so these are the situations. So again, at the van, you have the driving force minus the T minus the mg sine alpha minus the resistance. The resistance is for the resistance for the van is 2,500 is equals to the MA 4,500A. Maybe we write MA first. So your driving force is given as 9,100 minus a T minus the 4,500 times 10. Alpha is a 0.09 minus a 2,500 is equal to the 4,500A. Okay, so simplify it. You will get this one as a 2,550 minus a T equals to the 4,500A. That is your equation number 3. Then at the trailer, okay, this one is equation number 2. It's just that I didn't mention. Okay, 2 into 1. Now we have equation number 3 over here. At the trailer, we have another one is that the T minus the mg sine theta minus the frictional force, the resistance force is 300. Then is equals to the MA. Okay, so we have the T minus the 750 times 10 times the sine alpha, not theta, alpha. 0.09 minus the 300 is equals to the 758. So from here, you will get the answer as T minus a 975 is equals to the 758. That will be your equation number 4. Take the number 3 plus the number 4. You join together, you get 1575 is equals to the 5250A. Press a calculator, you can get the answer A as a 0.3 meter per second square. Okay, so once you found the accelerations, to find the T, just use the equation number 4. Your T is equal to the 975 plus the 750 multiplied by A. Press the calculator and you'll get the answer T as a 1200 Newton. Done. This will be the answer for the question number 5A. 5B part 1, sorry, 5B part 1. Now we go for the 5B part 2. Find the speed of the van when it has traveled distance of 375 meter up the hill. So we already have the accelerations of the overall for the combinations of the trailer and the van. So we can just use A as 0.3. So since I went up the hill, we can just use the formulas of v squared equal to the u squared plus 2as. Okay, so we want to find the speed. The u is originally you're moving with a speed of 20 meter per second. 20 meter per second. So this one is 20 squared plus 2a. Acceleration is a 0.3. Okay, and the distance travel is, they mentioned 375 meter. So just press a calculator. You can get the answer as 25 meter per second. Done. This will be the answer for the number 5B part 2. And moving on, we have question number 6. Okay, now we take a look at question number 6. We have a cyclist is traveling along a straight horizontal road. The total mass of the cyclist and her bicycle is 80 kg. There is a constant resistance of the magnitude 32 Newton to the cyclist's motion, and at an instant when she's traveling at a 7 meter per second, her acceleration is 0.1 meter per second square. Find the power output of the cyclist. Okay, so we know that the power is actually the driving force multiplied by the V. Okay, that means your driving force is actually the P divided by V. Okay, now if you resolve the forces of the cyclist horizontally, you have a driving force. Okay, the driving force of the cyclist minus the resistance force is equal to the MA, Newton's second law. So we just put P over V minus the 32 is equals to the 80A. So when the V is equals to 7, your P, you do not know, your A is a 0.1. Okay, so these are the information given. So we have a P over 7 is equal to the minus a 32 is equal to 80 times A. So you have the P as a 280 watt. That is the answer for the part A. Done. Okay, now we want to move on to the part B. Find the steady speed. Steady speed means what? Steady speed means constant speed. constant speed. Constant speed means your acceleration is equal to 0. So find the constant speed that the cyclist can maintain if her power output and the resistance force are both unchanged. So we will back to these equations again. Okay, we back to this relationship again, but this time the accelerations will become 0. So I resolve the forces right now. The Fd minus the Fr equal to 0 because of steady speed. Because of steady speed. Okay, so your Fd is equals to the Fr. Your Fd is a P over the V, and your Fr is actually equals to 32. But they mentioned that the power is unchanged, so 280 over V is 32. Then we can find the V as the 8.75 meter per second. That will be the answer for the number 6B. And moving on, we have the questions for the C. The cyclist later descends a straight hill, going down, descends a straight hill with a length of 32.2 meter, incline at an angle of arc sine of 1/20 to the horizontal. Her power output now is 120 watts, and the resistance force now has a variable magnitude such that the work done against the force in the inclined hill is 1128 joule. The time taken to descend the hill is 4 seconds. Given that the speed of the cyclist at the top of the hill is 7.5 meter per second, find her speed at the bottom of the hill. So this one is a bit troublesome because we are having a variable resistance force. So over here, Newton's second law is not so proper. We need to consider the energy. Okay, so you want to consider the energy, work conservations of energy. We have the work done by the cyclist is equals to the, you're going down the hill, and we can see that, we can foresee that the GPE, the PE loss, the potential energy loss, okay, by the KE gain. Okay, then we have the work done by the resistance is also there, minus the PE loss. Okay, so this is the formula. And the work done, because we know that the power is actually the work done divided by time. Okay, so we can actually change the power work done to become the power times T. Okay, we can use this formula to find the work done by the cyclist. Okay, so the PT is equal to the half M. Okay, the KE gain, V square minus the U square, plus the work done by the resistance already given, 1128, minus the PE loss, mgh. Okay, so the power given is a 120, the time given is 4 seconds, the mass is 80, the V you do not know, but the U is 7.5, plus 1128, minus the M. M is a 80, G is a 10, the height, it will be 32.2. Okay, the height is over here. This is a 32.2 meter. This is the height, and this is the angle. So the height will be a 32.2 sine theta. Okay, so just use your calculator, simplify it. You get this one as a 480. This one is a 40 V square minus the 2250 plus the 1128 minus the sine theta is actually 1/20. Just put 1/20 here. Okay, so just press the calculator, you get 1288. So from here you can get your V is equal to square root of 72.25, and square root it, you get 8.5 meter per second. So this will be the speed of the cyclist at the bottom of the hill. Done. That is the answer for the number 6C. Moving on, we have question number 7. Okay, now we take a look at question number 7. The diagram shows a track ABCD with the line in the vertical plane. The sections AB is a straight line inclined at an angle 30 degrees to the horizontal and is smooth. This is smooth. The section BC is a horizontal straight line and is rough. The section CD is a straight line inclined at an angle 30 degrees to the horizontal and is also rough. The length AB, BC, and CD are 2 meters, all 2 meters. The particle is released from A at rest. The coefficient of friction between the particle and both BC and CD are mu. There is no change in the speed of the particle when it passes through either the point B or C. That means the speed over here and the speed over here, no change in the speed. No change in the speed. Okay. And given that you find the distance up the back. Out. So over here we have 3 stages over here. One is going down the plate, one is going, all one going up here. So in a big problem, if we want to break them one by one, I think conservation of energy will answer all these questions a lot faster. But then we need to find out the frictional force of the horizontal surface, the frictional force on the right. That will be the next thing. So this almost equal over here. That when we define here, your normal contact force is R1. This is the M. The M is not given. Then when you go up here or R2, and okay, so we need to find the DC and removing horizontal. How the force will see have R1 equal, then the frictional force will be 0.1. Then and DC at not be 15. Consider the forces perpendicular to you have the R2 equal to force ratio. So you will be cos theta is equal to so you have the 3/2 mg. Your frictional force and that part it will be Q R2 that will be 0.1. One more F. One more F. And it's just 0. 20. Okay. So this is what we have for the R1 and R2. Okay. Now, we can consider the energy right now, conservation of energy. So going down, that means your GPT loss. GPT loss. So when you go down the hill from here, we go down the hill. So it's the height.
So 2 meter by 30, so it will be n v of 2 by 30. And after that, when you reach here, you have the KE unit in the half of the maybe we write down the relationship first, the easier for us to solve it. So we have the PE loss is equal to the KEP. Now the PE plus the work done by the so the PE loss will be the communication and not the patient who's not the PE. KE loss, KE gain is the half n of the p square, the E is the 1. Okay. And GDP gain H, this H is distance now I mentioned this distance is T. So I mentioned this distance also the D. So the height of it is D by 30 degrees, D by 30. D by 30. Plus the work done by the distance. Work done by the distance FR1 multiplied by 2 plus the FR2 multiplied by 2. So we simplify first. We have different MD equals to the half M plus half MGD plus F R1 0.1 MG times 2 and the both have a distance of 2 because the factorizing out is not a vector using over P and giving so M M M M M and so get 10 equal to half plus 5E plus 2 plus so we are having this one is not 2. I make a mistake. This one is P. Because it didn't reach. And here it didn't reach until it reach until this P is the only. So this one is the FR2. So make a mistake. I'm not factorize the 2 parts. But multiply by 2. Plus the 3 over 20 and the P. So over here, one is going to the 3 over 20 also the F. So this one is also 7.5 is equal to the 5 plus the 3. So from here, the first calculator, we can find the B and 1.3. So this will be the answer for question number 7A. Like that. Done. Now we're moving on to the question number 7B. Now they take away the value for the U equal to 0.1. Now we do not know the new of the coefficient of difference with the correct. But if this new coefficient of difference, the particular E is able to travel bring 1 meter track from speed before it has a Newton cable track. Can you give the maximum speed? The maximum height of the speed. Okay, so we have to reconstruct everything again, but we think the formula more or less. So over here, we will having the conservation of energy as well. We will be having the EPC loss. Is equals to no more KE, KE no more because the n is also the beginning is correct, n is also correct. So we only have the work done by the resistance plus the PV of the system. So the PV loss over here is energy usage. We will be 2 multiplying by 3. The work done by the resistance, we have 2 surfaces. One is the FR1 multiplied by 2. One is the FR2 multiplied by 1 meter. Because it is 1 meter. Then the GPE here is the meter of 1 multiplied by 32. Okay. So I think these two can combine them together. So we will be having energy of 1 minus half. If you go to the, what is the FR1? FR1, we will use this formula. New energy, FR2 is the new R2. Okay. So we will be 2 new energy. Plus the FR2. FR2, R2 is the 3 of the energy. 3 over 2 D. Energy and energy transfer. And you get a half. Then is equals to 2 plus the 3 over 2. So from here, you can find the mu and the 0.17 opposite 5 over 2. I don't plan to leave the answer in the exact form because the question is required for the exact form. So I found the new position of picture already. So now I want to find after you reach to the top, after you reach to the maximum height of the TV, and you want to move down and speed you have half to speed again for the second time. Okay, so over here, again, is still using concentration of picture. So because I am moving down here, then this is the 1 meter. This is the 1 meter. So the height is still remain at the 1 multiplied by 30. So when you now below, now you have to find T here. The angle of the so we can use conservation. Find the conservation of energy. We have the PV loss is equal to the plus by the resistance. So the PV loss is calculated. The PV here is the half head of the P square minus the P square. The work done of the head is FR2 multiplied by the distance traveled. Distance traveled is 1 meter. So I do not know the n. I know the G as 10. The H will be 1 multiplied by 30. The M No. The B, I need to find the FR. This one is the 3/2 of U and B multiplied by 1. A, M, and N, and N factor. So over here, you get this one as 5. It goes to the half this way. Plus the 5/3 of 0.1744. Press the calculator, get the answer B as 2.64 meters. So that this will be the answer for the question number B, number 7B. And that will be the last question for this paper. So I'll stop the video here. See you next time.